In this lesson, we're going to look at the Cartesian coordinate system. The Cartesian coordinate system was created by a philosopher and mathematician, René Descartes. And if you do some internet research on him, you'll find some interesting things. One thing that I think is interesting and important to note, that he is considered father of modern philosophy. So he was pretty big, had a lot of ideas if they consider him the father of it. And then the only other thing that I thought was kind of interesting to point out is the phrase or the saying, I think, therefore I am, is one that he said, and it was referring to knowing that we're alive and things that because we're able to think and reason, we must exist. And maybe someday it'll help you on a Jeopardy question, but it's nothing you'd be ever responsible for knowing in the context of this class. Just information that's kind of interesting for background. The Cartesian plane is made up of a horizontal axis, which is the x-axis, and a vertical axis, which is called the y-axis. And these axes are made from number lines, and they intersect each other at 0. So if you were looking at the number line for our x, our horizontal, this point here would be 0, and then to the right we would count 1, 2, 3, 4. It says that sometimes they'll count by other units than 1, and if there's no numbers there, assume it is 1. But sometimes if you have large numbers you're dealing with, they might count by 2s or 5s or even 10s. And then to the left of 0 would count our negatives. So -1, -2, -3, and so on. And then the same thing with our y-axis. It's like turned to the side. So the positive numbers 1, 2, 3 are going above the 0, and the negatives would go below the 0. Each point on the Cartesian plane represents an ordered pair. And so we have, as you can see here, an x value and a y value. We always put the x value first and the y value second inside the parentheses, and they're separated by a comma. And it mentions quadrants. So if we look back here, notice that we have 4 squares, so to speak, 4 areas that are in our Cartesian coordinate plane. And to name them, you start in the upper right-hand corner with Roman numeral 1, and then you go counterclockwise for 2, 3, and 4. So when you do that, there are 4 different combinations of the signs that you get with the numbers. And so if we look at this first quadrant, we're going to the right of 0 on the x and above 0 to the y, which is positive for the x and positive for the y. So any ordered pair that falls in quadrant 1 are going to be 2 positive numbers. Quadrant 2, we're going backwards on the x, so that's negative, but we're still going above 0 for the y, so that's positive. For quadrant 3, we have backwards or negative on the x and down or negative on the y. So quadrant 3 is where you're going to have 2 negative numbers. This looks like I'm doing an emoji, I think. And then for quadrant 4, we're going positive on the x and negative on the y, so plus, minus. So there's the 4 different possibilities for number signs. So again, our positive was in quadrant 1. Our negative positive was quadrant 2. Our 2 negatives together was quadrant 3. And then the positive and the negative was quadrant 4. And it mentions the order is important. You always need to do the x value first and then the y value. And so it says that 1, 2 is different than 2, 1. So if you think of directions, and we're here at 0 for the x and for the y, 1, 2 would be count positive right 1 space for the x and then 2 spaces for the y. Where if we were looking at 0.21, starting at that origin where both are 0, we're going to go 2 spaces to the right and then 1 to the left. So it creates a different spot. So make sure that you're paying attention to the order of your x and y values. Now, when we're looking at the quadrant plane, we can find the ordered pair that is a given point by doing that same again. Are we going left or right from 0 on the x-axis? Or are we going up or down on the y-axis? So if we look at point M, we have to go backwards 2 spaces to get above the M on the x-axis. So that means that the x-coordinate will be -2. And then we have to go down 1, 2, 3, 4 spaces. Make sure you're not starting your counting at here being 1, otherwise you won't be able to get the correct answer because you're counting lines instead of spaces and counting that first line as 1 instead of at your starting point. That would be distance of 0, not a distance of 1. So point Q, we're going backwards again on the x. So we're going backwards 1, 2, 3, 4, 5, 6 times to get below the q. So -6. And now we need to go up how many times? We're going up 1, 2, 3, 4, 5. Yep. So -6, 5 is the ordered pair to point us to Q. And let's look at T now. On T, we have 1, 2, 3, 4. So we're going positive 4 spaces. And now we're going down 1, 2, 3. Now when I'm doing this, I'm drawing lines just so you can see me counting, but you don't need to draw to find those points on your paper. Just count boxes. Now let's practice plotting them when we are given the coordinate. Notice they already plotted B for us, 0.00. That's where we're starting at 0 on the x and 0 at the y. And 0, 0 is also called the origin. And so that's kind of the way I think of it. The origin is the start of something. So we're starting when we count from 0, 0, when we find our other points. So if they mention the origin in a problem, you know that they're giving you that 0.00. Point A will be at -1, 3. So we're going backwards 1 space and positive or up 1, 2, 3. So point A is right there. B is already put on there for us at 0, 0. C, we're going backwards 4 and then up 2. So 1, 2, 3, 4, 1, 2 puts us in front of our parenthesis here at point C. And then point D, positive and positive, we should be up in that quadrant 1. We're going right 1 space and up 3 spaces. So they have them all kind of close together for us. Here's point D. The Cartesian plane is a useful tool in math. It's commonly used a way to visually display the solutions for an equation that has 2 variables. An example of a linear equation in 2 variables is y equals 4x plus 7. X and y are our variables, our unknown numbers. So a solution to the linear equation in 2 variables is an ordered pair, such as 1 for the x and 2 for the, 11 for the y. So 111, which results in a true statement when the x and y values are substituted into the equation. One way to find solutions to a linear equation in two variables is to create a table to organize your numbers. And the ordered pair 111 is a solution to this problem they gave us, 4x plus 7, because notice that this was our y value, and they're putting y in for that, because remember, here's our y value, and 4 times x, so 4 times 1 plus 7, and when we do 4 times 1 plus 7, we get 11, so since it equals each other, it is a point that is a solution for this equation. And so here they're going to give us some examples of finding more than one point that are solutions. Since we have two variables, there can be multiple combinations of numbers that will give us a true statement when we plug them in. And so in this case, they're giving us one solution with the x value of 7 and a second solution with a y value of 5. So let's go ahead and see what we can do with those. So first it tells us to substitute 7 in the equation. And so let's do that. So we don't know the y value. We're solving for y equals 2 times, it's telling us to use x equals 7 minus 5. So 2 times 7 is 14. And so we have 14 minus 5, which equals 9. So the ordered pair 7, 9 is a solution to this equation. So it's one point that will work. Now it's asking us to use 5, but notice we have to put it in the y spot, not in the x spot, because it's y equals 5, and that's by itself. So 5 equals 2x minus 5. So to solve it, we'll add 5 to both sides. And when we do that, we get 10 equals 2x. So then we would divide both sides by 2. And then we will get a final answer of 5 equals x. So if we're given a y value of 5, the only x value that would give us a true statement to be a solution would be x is 5. So 0.55 is a solution of this problem. Now it asks us to pick another value for x and substitute it. And so let's go with x equals 0. That's an easy one to plug in. So we will get y equals 2 times 0 minus 5. So y equals 0 minus 5, which is negative 5. So a third solution to the problem is 0, negative 5. And then we're going to do a fourth point. This time it picks y value for, and it doesn't want us to use 5. And so when we do this problem, there's times where you pick a number and it can give you a fraction. That's fine. If we picked 0 for y, we would get a fraction answer. And again, that's fine, but sometimes we don't like working with fractions, so I picked one that I know will give us an easy number. And so I picked y equals 1. And so we'll have y equals, or 1 equals 2 times x minus 5. So we add 5 to both sides. We'll get 6 equals 2x. And then when we divide both sides by 2, we're going to get 3 equals x. So let's add that to our chart. We found x equals 3 when we used y equals 1. So again, our ordered pair is 3, 1. So now let's graph those on the coordinate plane that they gave us. So we had first 7, 9, 5, 6, 7, 8. Oh, I was counting 9 instead of 7. 7 and up 1, 2, 3, 4, 5, 6, 7, 8. Okay, way up here at the top. The next ordered pair we had was 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's our second point, 5, 5. And then our third point, we had 0, -5. So we're not going left or right. Going down 1, 2, 3, 4, 5. There's our third point. That's called a y-intercept because it's right on the y-axis. We'll talk about intercepts more later. And then we had 1, -3. So over +1, down 1, 2, 3. So there are the points for this equation. And if you notice, you are getting points that connect together. And so if I were to take a line and draw them through my points, notice that they all line up in a line. And that's what you'll end up doing when you graph these linear equations, linear means line. And so that shows us, let me try and get it skinnier so you can still see our points. Oh, it didn't change, that's okay. But we had our points on there. Here, 1, here, here, and here. And then arrows get drawn on either side to show that that line can continue on forever. So any point along that line would actually give us a true statement. Sometimes the points on the line are whole numbers, sometimes they're decimals or fractions. Every solution to a linear equation represents a point on the line of the graph of the equation. A line contains an infinite number of points, as we just talked about. So a linear equation has an infinite number of solutions. So here we're given 2 different lines and 1 equation, 2y = 3x + 4. So we need to figure out which line represents that equation, and then we'll know which points are solutions. So the first thing I notice is that the 2 lines cross. They cross here at this y-intercept. It's at 0, 2. And if I try that, it doesn't matter which line it is, it's going to be a solution because it's one for both. So that would not be a good one to check because, yes, I'm going to know it's a solution. So we know that 0, 2 is going to be a solution of that line. But it's not going to help me determine which line it is because it's on both. So let's pick a different point to check. Let's check this. If we get a true statement, we know that that line that connects those 2 points together, and then we have that third point will be it. If we get a false statement, we know it has to be the other one. So first, let's figure out its ordered pair. We're going right 2 and up 1, 2, 3. So that's point 2, 3. So we need to know, is that going to work or not? So 2 times y, or 2 times 3, equals 3 times x, which is 2, plus 4. I can already see no because we have 3 times 2 and 2 times 3. So we have 6 equals 6 plus 4. So 6 does not equal 10. So what that means is, nope, this didn't work over here, so this one's not going to work either. And so our solutions, we already have 0, 2, but this point is going to be a solution, and this point, because it's the other line, that's the graph of our equation. So let's figure out those other ordered pairs. We're counting right 1, 2, and up 1, 2, 3, 4, 5. So we have 2, 5 will work. And if we plug that into our equation, we will get 10 equals 10. And then the other point that works is backwards 1, 2, 3, 4, and down 1, 2, 3, 4. So backwards 4, down 4. And if we get that, we will get negative 8 equals negative 8. So again, we will get a true statement if we plug it in to our equation. Here you have two tables to fill out. They give you either the x or the y value. For number 8, notice you have fractions. You can plug in using fractions, but what I like to do is get rid of fractions. I know that 4 can divide by 2 evenly, so my least common denominator here is 4. So if I multiply everything by 4, the entire equation, I'm going to get something that eliminates fractions. And so 4 times a half would be 2. So we have 2x minus 4 times 4 is 1. So we have 1y, which we can make the 1 invisible, so just minus y equals. We can't forget to do 4 times 12, even though 12 is not a fraction, we have to multiply everything. So equals 48. So I could use this equation, 2x minus y equals 48, if I wanted to use numbers that aren't fractions with that one. And notice 7 is simple, y equals 3x. We have an invisible plus 0 if you want to think about it like that, because every other problem that we've had a number attached with it, but it's not important. As long as we have something with an x or something with a y, we can have a line. Okay? So try these on your own, and then when you're ready, we'll do some application problems together. So here we have a map. Maps are using grids, which needs ordered pairs. A lot of times, like with Battleship, they might label one axis with letters instead of numbers, but it's still using this XY coordinate idea. And so we need to look to see which places traffic signals will be put, and the traffic signals are indicated with stars. So 1, 7, let's find that spot in red. Over 1 up 7 is here, and that's a no. There's no star there. 4, 4, we'll check that in green. Over 4 up 4, yay, we have a star. So that one will get a traffic signal. And then 0, 5, we're not going to the right, we're staying at 0, and up 5 would be here. And that's a no. So there's not one there either. So now which points not listed will be getting traffic signals? So let's identify those. So we have another star here, which is over right and up 2. So we have ordered pair 1, 2. And then if we look at another spot, we have way up here above the other one, so we're still going over 4. But now we're going up to 7. And so we have 0.47 as well. Here, we're using time equals distance divided by rate, and they're giving us a total distance of 150 miles per hour. And so they're saying the time that we're doing our unknown for is going to be the distance, which is 150, divided by the rates, which they give us in the chart. So if we do that, 150 divided by 25 would be 6. 150 divided by 50 would be 3. 150 divided by 60 doesn't come out evenly, so that would be about 2. It would be exactly 2.5. So now they want to graph it. Notice they're having us change the scales because we don't want to do 60 boxes. And it says graph the ordered pair using a scale of 10 for each rate. So these are going to be counting by 10. So that's 10, 20, 30, and so on. And then the time will still stick with ones. So for our first one, we have 25 and 6. So since we're counting by fives, or sorry, tens, 10, 20, 25 will be halfway in between 20 and 30. We're going up 6. 1, 2, 3, 4. So we're in between here for our first point. Our second one, we're at 50. Let me erase those red marks so it doesn't look like we're trying to graph those. So we're going over 5 blocks, which is 50. 1, 2, 3, 4, 5, and we're going up 3. 1, 2, 3. And then at 60, we're only up 2.5. So here's 60, up 1, 2, and 2.5 or 2.5. So again, if you've done your math calculations right, you should be able to see a pattern that follows a line. In this case, our line is going downhill. And if I could draw a straight line, you would see it even better. But that helps us with answering C. Let me get this line, and I want it skinny. So there's my line. And so we can see that the rate or the speed increases. I guess we should word it the other way because it's asking us the value of the time. The time decreases as the rate or the speed increases, which we know that the quicker you go, the less time it takes you to get there. That's why my husband likes to drive, because he says I'm a slowpoke. Here's another part. So, what happened to the first part of question 11? Anyway, 11 says, never mind, that's not for question 11. What question is this for? I don't even see this problem in my papers. Oh well, I guess that means we get to skip it. Sorry about that. Let's go to 11 now. Suppose you deposit $1,000 into an account that earns a simple interest rate of 4%, and we're using the formula I equals PRT. And so it mentions that we have 3 months, 6 months, a year, 2 years, 3 years, and we're supposed to find out the interest for a $1,000 deposit. So we're going to do the principal, which is 1,000, times our rate, which we know is 0.04, and then times the time is going to change. And make sure you use time in years. And so if you notice the table, they already did that 3 months. They changed it to 1/4 of a year. 6 months is a half a year, and then 1, 2, and 3 years. So we just start plugging in the values. One thing that's nice to do is, since everything's going to be multiplied by 1,000 times 0.04, we can simplify it and say that we're doing 40 times t. So 40 times 1/4 would give us 10. Half of 40 would be 20. 1 times 40 is 40. 2 times 40 would be 80, and 3 times 40 would be 120. Okay, so we're supposed to plot that and then draw a line through them. And so let's count since we had a quarter year, then a half year, let's count by 1/2. And then since our numbers were in tens, let's count by tens on our I-axis. So for our time at 1/4, we're up at 10, so we're at 1/2 of a half, and up 1 box for 10. Then at a half, we're up at 20. At 1, which is 2 halves, we're up at 40. At 2 years, we are up at 80. So 1, 2, 3, 4, 5, 6, 7, 8. And then at 3 years, here we're up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'd be up here at $112, which would be the 12th line, $120. And so our line, if we were to draw it, oops, that's not drawing, is it? Trying to get it to do it. We go up like this. Perfect. And so since the graphs are models of situations that can be used to predict values, we can look at this graph and predict after 9 months. And so 9 months is 3/4 of a year, so that would be over to halfway in between the first and second. And notice we will be up at $30. Oh, I'm trying to draw a line. There instead of number. There we go. And after 1.5 years, half, 1.5, we're up at $60. And we could use a formula to get those numbers as well. Well, it looks like that's the last question. So if you have any questions while you are working on your homework, please don't hesitate to screenshot it and send it to me. I'd be more than happy to help you. Otherwise, I'll see you next time.